video looks at formula and its definition and how to calculate it. Empirical formula is related to molecular formula, so I'm just going to introduce that first. Hopefully you're all aware that molecular formula is the actual number of atoms of each element in a compound. So for example, ethane has a molecular formula of C2H6, so 2 carbons and 6 hydrogen atoms. Empirical formula has a similar but different definition. So it is the simplest whole number ratio of atoms of each element in a compound. So the blue part is the same, it's just this first bit is different. So the simplest whole number ratio. So for ethane, for example, we can simplify that. We could divide through by 2 and we would get CH3. So CH3 is the empirical formula of ethane. So how do we go about calculating empirical formula then? So here's an example. So we've got, you're often either given a mass or a percentage. So here we've got this mass of carbon here and this mass of hydrogen here. And if you just follow a certain procedure, this works well. So the first thing is to create columns for each element. So carbon and hydrogen. Second stage is to divide by the relative atomic mass of each element, effectively working out the moles. So divide by 12 and 1. Get this answer here. Third off, you divide by the lowest answer. So of these 2 answers, this is the lowest answer here. This is the smallest answer. So we divide through by that. This will come out now as 1. Anything divided by itself will always come out as 1. And hopefully we will get whole numbers at this point. So if we have a look at that, well, we sort of have 2.998 is very, very close to being 3. So if you get answers of 2.998 or 3.002, you can take that as being, at that point you would round. There is a stage where if it doesn't come out as a whole number, we'd multiply through. I'm going to miss that out for this one. I'm going to do it on the next one. But the final stage on this one would be to write the empirical formula. So don't forget to actually write it. So 1 carbon, 3 hydrogens, the empirical formula is CH3. So let's do one which has this stage in. Okay, so this one has got Fe and O. These are percentages here. It doesn't matter. You treat it all in exactly in the same way. So the first stage again would be, and if you want to do this, you can always pause the video here and have a go at this yourself and then just check your answer. So create columns for each of your elements. Divide the mass by the relative atomic mass. So there we go. Each element on the data sheet. Divide by the lowest answer. So there's, of those 2, 1.253 is the lowest answer. So this one should come out as 1. But now you can see that this is coming out as 1.50. So at this point here, we would multiply through if necessary. So looking at that, I can quite clearly see that if I multiply through by 2, then that is going to become 2, isn't it? And this is going to become 3. Sorry about my fighting with a mouse. So that is the simplest whole number ratio. So don't forget to write it. And it becomes Fe2O3. Okay, just a few things to say before I finish. What are common errors? Common errors are rounding. So these, this is quite unusual here, that these percentages are to 4 significant figures. So 1, 2, 3, 4. So when you're doing the calculation, you should really stick to 4 significant figures when you put your answers. Obviously, you can keep it in your calculator, the full answer, but when you're writing it down, don't go under 4 significant figures until you hit this kind of area here. If you go down to under 4 significant figures here, it can create errors in your calculation. So the worst situation is that I see sometimes is that you go down to 1 significant figure. So that would become 1 significant figure, and that would become 2. So at that point there, you're getting a formula of FeO2. So that is the major problem with this, where students go wrong. They round too much, stick to the number of significant figures in the question. Don't go below it, and then you won't go wrong if you follow the methodology. Oh, one final thing is whenever else would you multiply 3? Well, other ones, obviously, when you hit a half, you're going to double through. But if you hit like a third as well, that's quite a common one. So if you get 1.33, or you would times by 3, or 1.25, you would times by 4. But if it's, as I say, 1.99 or 2.02, there's no need to do that. You would just round to the closest whole number. Okay, hopefully you're finding these videos useful. If you are, please subscribe, and then you'll get notified about when I do some more. I'm just going to create them as I go along this year. Thank you.